Okay, so we're on part 3 of the spring interim. We're on question number 8. And question number 8 says that Anya is wrapping gift boxes in paper. Each gift box is a rectangular prism. The larger box has a length, width, and height twice as large as a smaller box. Which statement shows a relationship between the surface area of the gift boxes? So if you look here, notice that for question number 8, they did not show us any pictures at all. They did not give us any pictures, which means that we're going to have to resort to our rules, right? Rule number 2, draw a picture. And rule number 3, input the numbers. So the first thing I'm going to do is I'm going to draw a picture and input the numbers. Oh, and by the way, notice that all they told me was that the larger box has a length, width, and height that is twice as large as a smaller box. Well, what's the numbers, right? They didn't give me any numbers, which means that I'm going to have to use rule number 4. If they don't give you any numbers, use your own, like 1 and 2. So I'm going to use my own numbers here. So what did I do here first? Well, the first thing I did was I drew a rectangular prism, right? I drew a rectangular prism and I made my own numbers. I made the length, width, and height 1, right? Then what did I do after that? Well, they told me that in the question, it tells me that the larger box has a length, width, and height that's what? That's twice as big. So what did I do? I just drew another rectangular prism and I made the length, width, and height twice as big. Since I picked numbers 1, 1, and 1, all I had to do here was put numbers 2, 2, and 2. You know, you could have picked any numbers you wanted here. You could have put 1, 2, and 3. And as long as you made the numbers twice as big here, which would be 2, 4, and 6, you're going to get the right answer. So take a look here. I drew my first picture. They didn't give me any numbers, so I put the numbers 1. I put in my own numbers. Then I drew a new picture, and I put in the numbers in relation to those. It's twice as big, so everything is twice as big. Then what I did here was I calculated the surface area of all of the sides, right? So this area, this box here, 1 times 1, the area of this box here is going to be 1 inch squared, right? But a cube has 1, 2, 3, 4, 5, and 6. It has 6 sides. So 1 inch squared times 6 sides mean that the surface area of this entire cube is 6 inches squared. Then over here, I got, 1 square, which is 2 by 2, right? So the area of this shaded here is going to be 4 inches squared. So one face of this cube is 4 inches squared. But how many faces does a cube have? It has 6 faces, right, guys? So the 4 inches squared that I got here times the one in the front, the one in the back, and then the 4 all around, that's 6 faces, right? So 4 inches squared times 6 is 24 inches squared. So I can see here that my first box has my first rectangular prism has a surface area of 6 inches squared. And I can see that my second has a surface area of 24 inches squared. And I can see here then that what happened to the surface area? It went from 6 to 24. Is that double? 2 times as large? No. Is that 4 times as large? And yes, it is. 6 times 4 is 24 times as large. And listen, it doesn't matter what number you picked. No matter what numbers you picked for the first one, if you double them for the second one, they're going to be 4 times as big. And the answer was going to jump out at you. Okay, so the answer to number 8 is going to be B. But remember, you got to draw the pictures. You got to input your own numbers. Draw the second picture. Put the numbers that correspond to the scenario. If it's twice as big, then I made all the numbers twice as big. Then what? I solved the surface area of this rectangular prism. Then I solved the surface area of this rectangular prism. And I just compared them. Okay? Question number 9. Let's move on to question number 9. They want to know what is the distance between 4 and -1 and -2 and 3, between those 2 points, right? Well, if you take a look here, I got my reference sheet. I look to the distance formula right here, right? I have my distance formula here. So the first thing you're going to do for these coordinates is you're going to label them x1, y1, x2, y2. After I label them, I write down my distance formula, right? Here it is. Got it from the reference sheet, right? And then I'm just going to plug in, well, what's x number 2? It's -2, right? And then minus, what's x number 1? Which is 4. -2 minus 4. What's y number 2? Y number 2 is 3. And that's going to be minus, right? Y number 1, which is what? Which is -1. And I'm not going to get into the details of adding and subtracting integers. By now you should know how to do that. So and again, you can pause this and look at this math. So when I plug in all of the numbers into my distance formula, I get 52. Remember, this is all happening under the square root of 52, which means that it is 7.21. The square root of 52 is 7.21. So when you look here, you go, oh, wait a minute. None of these are the square root of 52, right? Well, the thing is, one of these is equivalent to to 7.21. In case you forgot, what two numbers give me 52 when I multiply them? 4 and 13. So it's the square root of 4 times the square root of 13. 4 is a perfect square, which comes out to be 2. So the answer is 2 times the square root of 13, which is choice D. If you forgot how to do this, it's okay. Let's focus on the 7.21. One of these has to be equal to what? 7.21. So if you notice here, I'm going to grab my calculator, right? Let's do the first one. I take 17, right? I take the square root of 17. Excuse me one second. I take the square root of 17. That gives me 7.21. The answer is, well, sorry, my calculator isn't answer, but if you do it, the answer is going to be no. If I take the square root of 34 in a calculator, it's not going to give you 7.21 either. And if in letter C, 5 times the square root of 2, well, you're going to have 5 times the square root of 2, which is, I believe, is 5 times 1.71 if I'm not mistaken. But when you multiply those two together, it's not going to give you 7.21. However, when you multiply 2 times the square root of 13, whatever that is in a calculator, when you multiply those two together, it's going to give you 7.21. So if you forgot how to take the square root of a radical, you can just plug these into a calculator and you can match it up, and that's going to give you your answer, which is choice D. Let's move on to question number 10. Okay. Question number 10 says, the opposite sides of a window frame are congruent. Okay, so here's a window frame. I know that these two sides are congruent. I know that these two sides are congruent by the congruency dashes. They want to know what additional piece of information would verify, that means prove, that this is a rectangle, right? What piece of information would verify that this is a rectangle? Well, first of all, if this was a rectangle, I know that these would all be right angles. I also would probably know that the diagonals bisect each other. So let's take a look here. What would verify it? That angle A is congruent to angle D. Well, does that tell me that this is a rectangle? Well, if this were a square, right? A, B, C, and D. If this were a square, angle A and D would also be congruent. So that doesn't really prove anything for me. Letter B says that AC is congruent to BD. And they don't draw it here, but here is AC and here is BD. And yeah, I know that the diagonals are what? They are congruent to each other in a rectangle. So that right there should be a little red flag should go off. Letter C, that AC is perpendicular to BD. AC and here is BD. They are not perpendicular. No, sir. That would have to be either a parallelogram or a rhombus in order for that to happen, and these are not perpendicular. And finally, that angle A and angle D are supplementary. Yeah, they are, but so they are also in a square. So that doesn't prove anything that it is a rectangle. So the answer to number 10 is letter B, that the diagonals are what? They are congruent to each other. Let's move on to question number 11. Question number 11. It says Max is constructing two tents as shown at the right. Here I have my two tents. In the diagram, they tell me that AB, okay, is congruent to DE. And what did I do? I marked them up. It also says that AC is congruent to DF. Here's AC. It's congruent to DF. During the construction, we determined that angle BAC is 35 degrees. Here's angle BAC. It's 35 degrees. Angle EDF is 33 degrees. So, okay, so again, what am I doing, guys? I'm reading the question and I'm marking up my image, right? I know that these two sides are congruent. I know that these two sides are congruent, and I know what the measure of these angles are, right? they want to know which of the following can we conclude, right? Well, if you remember, we said we know that these two sides are congruent to each other, right? But I also know that these angles are not the same size. And I also know that these angles correspond to a certain side on the triangle, right? I know that angle A right here corresponds to this side of the triangle. And I also know that angle D corresponds to this side of the triangle. And I know that if this is 35 degrees between these two sides, and I know that this is 33 degrees between these two sides, well then, if this angle corresponds to this side, and this angle corresponds to this side, and this angle A is bigger than angle D, well, I know that this side here is going to be bigger than this side here. Does that make sense? So I know that that side BC is going to be bigger than side EF because this angle here is bigger than that one. So BC is bigger than EF, and if you look at the choices, that is going to be choice D. BC is greater than EF. Okay,